Okay, so how do we evaluate inverse trig functions? So sometimes they're going to have special angles, or reference angles. And so let's just think about these. So inverse sine of 1/2. Well, inverse sine, remember, we're going to be in quadrants 1 or 4. And we think back to our table, sine of 1/2 is pi 6. So we just say pi 6. That's all there is to it. Okay, sometimes it's a little bit trickier. What about the inverse sine of negative square root of 2 over 2? Okay, well, let's think. What do we know from our table? Sine of what equals square root of 2 over 2? Well, sine of um, pi fourths equals square root of 2 over 2, right? Um, all right, well, how about negative square root of 2 over 2? That's down here, and we're going to have to use, so our reference angle there would be pi fourths, right? But the angle that we're looking for that gives us a sine value of negative square root of 2, here, let me move myself out of the way, that gives us negative square root of 2 over 2 here, the angle is 7 pi fourths. Is 7 pi fourths the way we refer to this? We're actually going to refer to this as negative pi fourths. Okay? We're going to refer to this angle as negative pi fourths because we're going from negative pi halves to pi halves. Okay, so in terms of negative, between negative pi halves and pi halves, the way we would refer to that angle is negative pi fourths. Okay, so if we're finding the inverse trig function of like a reference angle, first we think of, okay, the reference angle is pi fourths. We know that from our table. And that means that it's going to be negative pi fourths for sine. Okay, ignore this little thing. That's just like a mistake that I made in creating this slide. That doesn't mean anything. Okay. All right, well, so let's look at this next one. Inverse cosine of negative square root of 3 over 2. Okay, well, cosines are x values. So cosine of what equals square root of 3 over 2? That's going to be pi sixth, right? Okay, so we're going to say, so we're talking about cosine. So the negative square root of 3 over 2 is going to be over here. And we're going from 0 to pi. So we could refer to this as 5 pi sixths. Okay, so that's going to be the answer. Cosine of what equals negative square root of 3 over 2? The answer is 5 pi sixths. Okay. How about inverse tangent of 1? Okay, well, I know that tangent of pi fourths is 1. And that's that's between negative pi halves and pi halves. So the answer is just going to be pi fourths. Okay. Good and bad news. I guess the bad news is, first, you're going to have a new quiz, okay, where I will give it to you in class and put it on in our classroom, where it's going to be built on everything you already know, okay, but it's going to be about inverse trig functions like this, okay, so that you will have that to refer to. You're not going to have to go through this process every time. You're going to be able to just refer to this table to answer questions like this, because you can see it's a little bit complicated every time to think through this. Sometimes a table for this would be helpful. So we'll talk about it in class. I'll give it to you. It's going to be the same as last time. You're going to be able to take as many times as you need, but you're going to have to get it all right. So that's in your future. Okay, what if we don't have a reference angle? It's just like some number like 0.97. What's the inverse sine of 0.97? So you're just going to use a calculator. So you're going to find your arcsine button or your sine to the -1 button, whatever yours looks like. Make sure that you can get these answers. Let me move me again. So it's either in radian mode, it's going to give you this. In degree mode, it's going to give you this many degrees. Okay. So notice, what can you find the inverse sine of? Can you find the inverse sine of 3? Sine of what angle gives you 3? You could try it in your calculator or just think about it. Nothing, right? Because sine only goes from -1 to 1, right? So trying to find the inverse sine or cosine, your inputs, your domain is only between -1 and 1. Okay, what if we have a triangle? We want to find the angle. So this is like an actual practical application of this stuff. All right, well, the first step is we've got an angle here. We have an adjacent side and the hypotenuse. So we could write cosine of theta equals 9/12, right? And then we can say, well, theta equals the inverse cosine of 9/12. And we can put that in our calculator. And it's going to give us a radian or a degree estimate. And that makes sense. Yeah, about 41 degrees, about 0.7 radians. Sure. Okay, so that's how we're going to do this a lot more in just a minute, right? But that's how we have a triangle. You just write the relationship, right? Say cosine of this angle equals adjacent over hypotenuse. If we had the sine over here, if we knew that if we had the side over here, if this was 9, we'd say sine of theta equals 9/12, right? It just depends on which sides you have for which ratio you're going to write your initial equation for.